All right, notes 51 is a continuation of notes 49 where we're graphing quadratics. So there's two questions on here. I'm going to go through and do both. So let's see what we got here. We have this fabulous equation here, and I want to know all of these things. So thing number one, I'm going to find the axis symmetry. X is equal to the opposite of b over 2a. So our b value in this problem is negative 12, so the opposite of that would be positive 12. 2a is 2. So 12 over 4, axis symmetry is going to be x equals 3. Now, that axis symmetry, of course, gives us half the vertex value. So that's going to be the value of 3 for x. So we need to figure out what y is. So y is equal to 2. Everywhere I have an x, I'm going to replace it with a 3. 12 times 3, and then plus 16. So actually, I'll do this in one step here. No, I'll leave it as. So I'm arguing with myself here. Sorry. 3 squared is 9. So I'm going to end up doing 2 times 9. Negative 12 times 3 is negative 36, and then plus 16. So it's going to be 18 minus 36 plus 16. And that should be, I believe, negative 2. So let's see. 18 plus 16 is 34. 34 minus 36 would be negative 2. Yep. So that is the vertex there. Let's do some zeros, some x-intercepts. So we're going to make y equal to 0. So 0 is equal to 2x squared minus 12x plus 16. And I want to factor this. But before I do any kind of, split the x squared or anything like that, I want to look at these three terms and recognize that all of them have a common factor of 2. So I'm going to go ahead and factor that out. And then I'm going to look to factor this trinomial like I like how to do. So we're going to split up the x squareds. We're going to split up the 8. So what multiplies to positive 8 adds up to negative 6. So how about a negative 4 and a negative 2? And then you're going to set the factors equal to 0. Now, the problem is you have a factor here of 2. And last I checked, that factor of 2 is not going to equal 0. So if you were to write it out, 2 equals 0, that's not a true statement. So we're just going to ignore that one. There's no variable there, so you're not going to get an actual x-intercept from it. Only the factors that have variables in them will give you information on the x-intercepts. So x minus 4 equals 0, that means x equals 4. X minus 2 equals 0, that means x is equal to 2. So my x-intercepts are going to be 4, 0, and 2, 0. For my y-intercept, I'm going to write the actual letter you're looking for, x equal to 0. And I'm going to shrink down this work that I just did for the x-intercepts. And so let's talk about y-intercept here. We're going to make x equal to 0. So y is equal to 2 times 0 squared minus 12 times 0 plus 16. So 0 squared is 0, 0 times 2 is 0, 12 times 0 is 0, and 16. So 0 plus 16 is, 16. And so we have our y-intercepts, we've got our two x-intercepts, we've got our axis symmetry, and of course we have our vertex. So those are going to go on the graph. So 1, 2, 3, negative 2, we're right here. 0 is going to be 4, 0, and 2, 0. 0, 16, ooh, that's a very far away point. And axis of symmetry is x equals 3. So a line that goes through that x-axis, whoa, that's horrible, goes through the x-axis at positive 3. Right? If you were to fold the graph on that line, everything on the left side would match up with everything. Whoa, that's horrible. Everything on the right side. That's what I get for trying to draw with highlighter. All right, so let's go ahead and play connect the dots. Going through your points, but please make sure. Wow, that's horrible. Let's try that again. Hold on. My hand just took off and went some weird direction. Let's try and make this curve. That's better. I like that a whole bunch more. All right, there we go. Looking a little bit better. Still not perfect, but I'll give it points for being there. All right, so we've got the curve in the right place. We've got the vertex, x symmetry, zeros, x, y-intercept, all the things. Domain here is going to be your possible input values. In this case, you can input anything. So x is from negative infinity to infinity for the domain. And the range here, we have a lower boundary. So the lowest value we can get to is in the vertex. That's that y value of -2. Highest value is infinity. So there is our range. So -2 to infinity. All right. I'm going to move on to question number 2 because question number 1 is completely done. And we're going to repeat the process. All right. So sliding on down here. First thing I'm going to look for is, of course, my axis symmetry. X is equal to the opposite of b over 2a, which means x is equal to, your b value is -2, so the opposite would be +2. And your a value is -1, so 2 over -2, your x symmetry is going to be -1. And so we have that. That, of course, also gives you the x value of the vertex as -1. It's the y value that we're not going to be looking for. So let's see, we've got y is equal to -1 squared minus 2 times -1 plus 15. Be super careful with your signs. All right, make sure that you're putting all the ones in that you need. So in this case, we had x, which was -1, but there was a negative in front of it. So -1 squared minus 2. Replace x with -1. Yep, I got all the pieces. All right, so -1 squared is 1, but I need to make it negative, so it's going to be -1. -2 times -1 is +2 plus 15. Let's see, that would be 16. So I've got a vertex of 16 there. Let's talk about my zeros, my x-intercepts. All right, so to find the x-intercepts, we're going to make y equal to 0. So 0 equals -x squared minus 2x plus 15. I'm not a huge fan of the negative here. In prior videos, I moved everything to the left side to make it positive, so that's exactly what I'm going to do here. When you do that movement, all of your terms change sign. So the x squared that was negative and the 2x that was negative are now becoming positive, and the 15 that was positive becomes negative. Reason I do this is because I am much more confident factoring when my x squared is positive. So I went ahead and split the x squared. What multiplies to -15 and adds up to +2? How about a +5 and a -3? So that's going to get me, let's see, x plus 5 is equal to 0. X minus 3 is equal to 0. So subtracting 5 from both sides, you're going to get x equals -5. Adding 3 to both sides, x equals 3. So my zeros are going to be -5, 0, and 3, 0. I wrote a little on the large side, so let me just slide this off to the side here. I can still see all the pieces I'm working with, so I'll work with that. So there's my 2 zeros, my x-intercepts. Let's find a y-intercept. For the y-intercept, we're going to make x equal to 0. So that's going to be y is equal to -0 squared minus 2 times 0. And I, of course, ran out of room. All right, I'll slide that down. So then plus 15. So 0 squared is 0. Make it negative. You can't. It's still 0. -2 times 0 would be 0. So 0 plus 0 plus 15 would be 0, 15 for your y-intercept. If you've got your y-intercept and all the other bits, parts, and pieces, let's go ahead and put those bits, parts, and pieces on a graph. So -1, positive 16 is way up here. -5, 0, 1, 2, 3, positive 3, 0 on the x-axis. 0, 15 way up here. So then axis of symmetry would be that dotted line through the vertex, which was at -1, right about there. And then the curve through this one, this graph is going to be concave down. Your x squared term was negative. So when we play connect the dots, make sure you curve through your vertex Do your best to hit all the points up and down. And that is your pretty little curve. We've got two more pieces to answer, which are domain, so negative infinity to infinity. These quadratic equations that we're dealing with, if they're functions, you're going to have infinity to infinity because there is no boundary on how far to the left or how far to the right this graph will go. You can input any x value you want into it. And last but not least, we have a range. How low does your graph go? It goes to negative infinity. But when we talk about how high the graph goes, there is a boundary. And that boundary line is your vertex. And that vertex has a y value of 16. So that is the upper end of your range. That is the highest y value you can get out of this function. All right, I'm sure this video has been long enough, and those are the two problems for Notes 51. As always, let me know if you have any questions or concerns, and I'll see you in the next one.